Hey everybody, it's time to talk about voltaic cells. And so keep in mind that with electrochem and redox reactions, you have a exchange of electrons. And so what we're going to do is we're going to harness that exchange of electrons, going from the oxidation where you're losing electrons. Those lost electrons are going to go through something, and then once they move, they're going to go to the reduction side. So the oxidation, reduction, and we do this by splitting the reaction container into two parts, where we have the oxidation thing that's giving up the electrons happen, and then the reduction side gaining the electrons, and they happen. And so that way we can direct the electrons through a wire. And so you'll hear the word voltaic cell. Sometimes you'll hear a galvanic cell or an electrochemical cell. These things are also called piles. Galvanic pile, voltaic pile, electrochemical pile. Sometimes I just call it a battery. That's kind of the easiest way to look at it. Okay, and so these are really batteries are really just harnessing the flow of electrons that are happening in the chemical reaction and turning that into electrical energy. Okay, and so there are electrodes. Some of the vocabulary that you have to know. Let's see, there are electrodes, and so there's a cathode and an anode. The cathode is positively charged. The anode is negatively charged, and I can tell you that. And I remember this because cats are positive influences in people's lives. I'm not a cat person, but that's what I hear. 90% of the pictures that are on the internet are cat pictures and things like that. And then there's the anode, and the anode, "and" typically means against or negative, like anti and things like that. So that's how I kind of remember which one's positive and which one's negative. Also, the cathode is where the reduction occurs, okay, and the oxidation occurs at the anode, and I remember that, okay, by the barnyard principle, okay, that I was taught when I was in chemistry. The barnyard principle, there's only two animals on my barnyard. There's an ox and a red cat, but they still all work together. So the anox and oxidation and the red cat is where reduction occurs. Okay, and the last thing that you need to know is that you can connect the oxidation and the reduction side of your reaction with a wire, but there has to be a way for ions to flow back across to keep everything balanced out, and this is what we call the salt bridge. Okay, and so that's the vocabulary of the voltaic cell. Now if we take a look at the voltaic cell, let's see what's going on here. Okay, and so what we have is a zinc electrode. Okay, we'll figure out if that is the anode. Okay, and oxidation is occurring here. Okay, and inside here we have zinc 2 plus ions, zinc sulfate, which is 2 plus ions. And notice, of course, there are sulfate ions floating around, but the sulfate ions are really just a spectator ion. Nothing is happening here to the sulfate ion. Okay, and so here now we have a copper electrode, and that's the cathode. Okay, and copper is so now it's copper 2 sulfate, so this is going to Cu2 plus, and the sulfate SO4 2 minus. The neat thing about this is that while electrons are flowing through the wire this way, notice that the sulfate ions are flowing this way. So it's what kind of keeps everything going in terms of charge balance. Okay. Another way to look at it, what's the charge of an electron? Electrons are negative, so we have all these negative charges flowing out here. Well, if there's so many electrons floating out this way, what we need to make sure happens is that negative charges go this way, okay? So that negative charges then can balance out. So if we have too many negative charges here, they'll build up and bad things will happen. So we want to make sure that the negative charges then from the sulfate come over on this side. That's what the salt bridge does. Okay, so let's talk a little bit more about what's going on. From this, we can determine kind of what's happening in the cell or the pile. Okay, so we have zinc is being oxidized. Okay, so Leo Ger, G-E-R. Okay, Leo Ger. So losing electrons. When you're losing electrons, what side of the reaction do they need to be on? Well, they need to be on the product side. So if this is being oxidized, that means that this is going to be zinc reacts to form zinc 2 plus 2 electrons. Okay, and so that's that reaction. And now copper is the reduction reaction. So reduction is gain, or gaining electrons there. So that means that you're going to have Cu2 plus 2 electrons going to copper. Okay, so now those are your half reactions. This half reaction, the zinc half reaction, is happening here. The copper half reaction is happening there. And so when you add this up, you get zinc plus Cu2 plus reacts to form zinc 2 plus Cu. And so now that we have this total reaction, what is happening? We have solid zinc is going to form ions of zinc. So what is happening, and this is the awesome part about looking and knowing the chemistry, looking at and knowing the chemistry of these cells, is that your zinc electrode, that's made out of zinc, that's where all the solid is going, and so that's going into here, and so now we're increasing the amount of zinc ions here, the positive ions, okay, and so that this electrode here, that electrode is getting smaller. Now, the opposite is true on this side. Okay, the copper ions here in the solution, Cu2 plus, are actually depositing onto the copper electrode, or maybe they're just collecting, there's copper, solid copper down at the bottom. Either way, we're having more copper on this side of the reaction, okay? And that is helping us determine kind of what's going on too. And so the concentrations, this is maybe the key illustrated point here, is that the concentrations are continually changing. Okay. The concentrations of zinc 2 plus is always getting bigger, and the concentrations of Cu2 plus is continually getting smaller. So regardless of what is our electrodes, okay, the concentrations are always going to be maneuvering around because they're changing around. Okay, and so that explains what a voltaic cell looks like. It explains some of the chemistry. It also explains some of the terms that we learned in the previous slide. Okay, have a great day.